Hey everyone, and welcome to The Explainer. Today we're digging into a really big story, one of the most important shifts in how we build for the web. It's the story of how JavaScript, the absolute king of the internet, was basically forced to grow up. And this isn't just about some new syntax. Trust me, this is a story about a full-blown revolution in web engineering. Okay, to kick things off, just look at this number, 98.7%. That's how many websites on planet Earth use JavaScript. It is the undisputed, unquestioned language of the web. Its flexibility and how easy it is to get started with, that's what fueled decades of incredible innovation online. So that leads us to the big central question, right? If JavaScript is the undisputed king, why on earth did the industry it built decide to stage a revolt? Well, the answer is what we call a crisis of complexity, a problem that JavaScript's own incredible success actually created for itself. And this gets us to something called the JavaScript paradox. See, the very things that made it so popular, the fact that it's so dynamic, so flexible, so forgiving, well, those exact things eventually became its greatest weaknesses. As simple little web scripts turned into massive multi-million line applications, that flexibility started to feel a lot more like fragility. To really get this, we have to look at the heart of the issue. It really all boils down to two totally different ways of thinking about how to build software. You can think of it as a tale of two contracts, dynamic typing versus static typing. I love this analogy because it just clicks. Think of plain JavaScript as a verbal agreement, like a handshake deal. You write a function, and you just kind of assume everyone's on the same page and it'll get the right kind of data. But TypeScript, oh, that's an ironclad, legally binding contract. Every single term is spelled out, it's detailed, and it is checked and double-checked up front. And that's exactly what static typing is. It's the process of verifying those code contracts before your program ever even tries to run. It's like having a lawyer, in this case, the TypeScript compiler, who reads every single detail of a business deal to find problems before you sign on the dotted line, not after the whole thing has gone sideways. So what happens when that handshake deal, that verbal agreement, falls apart? Well, this is the classic JavaScript nightmare. You've got a function, and it's built on an assumption about the data it's going to get. But then somewhere else in a huge code base, maybe months later, another developer calls that function with the wrong kind of data. And what happens? Boom. The whole application crashes at runtime for your actual users. That's a real bug that real people have to deal with. But with TypeScript, we have that ironclad contract. The compiler is our enforcer. It reads our explicit rules for what the data should look like, and it flags any problems instantly, right there in your editor as you type. That exact same bug gets caught and squashed long before the code ever sees the light of day. It never even gets a chance to become one of those dreaded 3 a.m. emergency calls. So you're probably asking, okay, why now? Static typing isn't some brand new idea. The answer is that the web itself just hit a breaking point. The sheer, overwhelming complexity of modern web apps made the old, flexible way of doing things totally unsustainable. This timeline really tells the whole story, doesn't it? Back in the 90s, we had the static web. Think GeoCities pages. Super simple stuff. Then in the 2000s, you get the dynamic web, with apps like Gmail starting to pop up. But the real explosion, the game changer, was in the 2010s with the single-page application revolution. Suddenly, we're building things like Figma and VS Code inside the browser. These are massive, incredibly complex systems where that old handshake deal model just completely falls apart. And at that massive scale, the little cracks in dynamic typing become giant canyons. You get this crushing cognitive overhead. Nobody on the team can remember what shape any of the data is supposed to be in. You get a paralyzing fear of refactoring because you're terrified that changing one little thing might break 100 other things you can't even see. And just working together as a team becomes a total nightmare of constant bugs. But here's the crazy twist in the story. While TypeScript was created to make code safer and more scalable, its most beloved feature turned out to be something else entirely. It was this massive, unexpected improvement to what we call the developer experience, or DevEx. Basically, the day-to-day quality of life for the person who's actually writing the code. This is all thanks to something called the TypeScript language service, and it basically gives your code editor superpowers. When you type a variable and a dot, the editor doesn't have to guess what you might want to do next. It knows. This gives you incredibly smart autocompletion, 100% safe and automated refactoring, and the ability to jump around a huge codebase with just a single click. It is absolutely transformative. And this right here is a crucial point. We've all seen code comments that are totally out of date or just plain wrong, right? They're just not reliable. But types in TypeScript, they're a form of documentation that the compiler forces you to keep accurate. It's like a living, breathing blueprint of your system that is guaranteed to always be correct. So after all that, where does this leave us? Well, let's look at the final verdict. The debate went on for years, but the data's finally in, and the industry has made a really clear choice. When it comes to building serious, scalable software, TypeScript has become the new professional standard. Just take a look at this data from the 2024 State of JS survey. It's not even a close race anymore. A whopping 67% of developers said they write more TypeScript than plain JavaScript. The momentum here is just undeniable. And the Stack Overflow survey backs this up, but it adds a really important detail. Among professional developers, people getting paid to build commercial software, that usage number jumps to over 43%. This isn't just some hobbyist trend. This has become a core professional engineering discipline. So what's the big takeaway for you? This tipping point framework is a pretty good guide. If you're writing a tiny script or just a quick prototype, yeah, JavaScript speed is perfect. But the second your project involves a team, or it's meant to live for more than a few months, or it grows beyond a few files, that's the tipping point. The safety and maintainability you get from TypeScript become pretty much essential. And that really brings us to the heart of it all. This whole movement, this whole revolution, it isn't about replacing JavaScript, it's about maturing it. As our web applications grew from simple toys into critical, global infrastructure, the language we used to build them had to grow up too. And TypeScript, that's what that maturation looks like. It's a sign that web development has truly come of age as a robust engineering discipline.